Now let me explain you how to do principal component analysis using R. One thing you need to understand, be it SAS or be it R, the syntax of doing principal component analysis is fairly simple. What is required that you should be able to make sense of the output. Let me show you how much simple the syntax is. It is as simple as that you are reading the data, you are running the print comp, here you are giving the name of the data, you are not giving the column 1 because probably column 1 is P1, P2, it only takes the numeric variable, and you are saying correlation equal to true. The reason of saying correlation equal to true is that you don't want to use covariance, you want to use correlation. Covariance divided by square root of x and y gives you correlation. Correlation is unit free, it is scale free, it does not get affected by the scale that you are taking. And then you run the summary command of this PCA with loadings equal to true and it produces the output. Now let me show you directly on R that how it is, and then I'll come back once again to the PPT. So here you have the data. Let me just read this data. Let me clear this environment and then I'll just show you the remaining part. So here you read the data. It is asking me to select the file. So I have gone and selected this data, which I have used in SAS as well. Now I have the data of all those 16 observations. Here P1, P2, this is a character field, all are numeric. I am running the principal component analysis and I am running the summary command. So I got the output. So it is giving importance of components, loadings, etc. I have taken these inputs in PPT so that I can comfortably walk you through what R has produced, and at the same time I can explain you that how similar or dissimilar it is from the SAS output. So now let me go back to PPT. So ensure that you have to take only numeric variable, and this is how the output comes. Now take a look what it has produced. It has very much produced what SAS has produced. The only difference is that, here it has produced the standard deviation of the eigenvectors or principal components, whereas this is the variance. So essentially 1.77 square if you do, you'll get 3.13. I can show it to you if needed in Excel. Let me, by the time Excel comes, let me just keep walking you through that. So here you have a standard deviation, then you have proportion of variance, which is very much what you are getting in SAS, and then you have cumulative proportion, which very much you are getting in SAS, 0.44, 0.69. So it had just produced the same thing. The difference it is not producing, but it's okay. After all, when you have standard deviation, proportion and cumulative, it serves the purpose. So that's what you have seen. If Excel has come up, I can show it to you, but anyway it is not coming fast. So you can actually square it, 1.77 square, it will come out to be 3.13. When Excel pulls up, I'll just show you that by doing this. Rest everything is very much what you are getting in SAS. Now the next thing, you see the loadings that has come here, and you will find that some places it has not populated. Now if you look at in SAS, you'll realize that there are those places have very small loadings. You'll figure out that anything which is less than 0.1 in absolute value, R has suppresses intrinsically. So everywhere when it is less than 0.1, it is not showing. It is showing 0.14, 0.11, but less than 0.1 it has not shown. So even 0.0986 it is not showing here. Rest everything it has shown very much the way it should show. Like 516, 313, 488. You'll notice one more thing. Something which has come here positive has come here negative. And that's actually, like in this particular case, it's alternative, because if you see, this has come negative here all, right? Everywhere it is positive, it has come negative. It is negative, it is positive, has come negative. But on third, it has come very much the way it is coming in SAS. Here it is totally negative of everything. Again, very much like what you are getting in SAS. But you don't need to bother with that. What you need to understand, that x-axis and minus x-axis is very much same. It is just how you are combining these variables. It's just the direction is changing. It's just the way things are getting computed, but both are very much the same thing. And obviously, like, you can construct principal components very much the way you're constructing, and this is what you are doing here. It is just you are taking in this direction or this direction, you'll ultimately find the same components.